This is the Year 11 Computer Science PEP Part 2. In your exam, you might be asked about RLE, so I'm going to step through the code to ensure that you are ready. On line 1, the variable pattern is assigned a value. On line 2, I is assigned the value of 0, and on line 3, count is assigned the value of 1. On line 4, we check this condition, while I is less than the length of pattern minus 1. Now pattern has 14 zeros and ones, well, combination of them within it. So pattern minus 1 will give us 13. I is 0, so while 0 is less than 13, we would go inside of this condition. And we'd end up here on line 5 at the if statement. If pattern I is equal to pattern I plus 1. Now the I here is referring to an index, so at the top you can see the two arrows. The green arrow is pointing at index 0, and the orange arrow is pointing at index 1. So if pattern 0, because we're inputting I, is equal to pattern I plus 1. Now I plus 1 would give us 1. So we're looking at the green value, and the orange value. Is 0 equal to 0? Well, it is. So we go down to line 6, and count would be equal to count plus 1. So now you can see that count has gone up to 2. We would then come down to here, and I equals I plus 1, so I would increment to 1. So now we come back around the loop, and we check if I is still less than 13. Well, I is 1 now, so that is still less than 13. So we come down to line 5, if pattern I is equal to pattern I plus 1. So we're looking here at index 1 and index 2, because pattern I plus 1 would give us 2. So the arrows at the top are representing this. Well, is 0 equal to 0? Well, that's true. So count equals count plus 1. We would then come down to line 11, and I equals I plus 1. Again, we would come round the loop. You can see here that while I is less than 13 is still true, because I is now 2, and 2 is still less than 13. So once again, we come down to line 5, and we compare pattern I to pattern I plus 1. Well, now I is 2, so we're comparing index 2 to index 3, and you can see that index 2 is 0 and index 3 is 0. So therefore they are the same again, so count equals count plus 1, so count is now 4. Again, we'd then come down to line 11, I equals I plus 1, so I becomes 3. Once again, we go round the loop, because we're stuck in this loop until the condition is met, while I, which is 3, is less than 13. Well, it is, so back down to line 5 again. So now we're looking at index 3 and index 4, and both of those are 0. So is 0 equal to 0? It is, so count equals count plus 1. Again, we would come down to line 11, and I equals I plus 1, so I is now 4. Again, we come round the loop, because I is now 4, and 4 is still less than 13, so we come down to line 5, and we look at pattern I is equal to pattern I plus 1. Well, the I is 4 this time, so we look at index 4 and index 5, because I plus 1 would give us 5. And you can see, as shown by the arrows at the top, 0 is equal to 0, so therefore line 6 would run, and count equals count plus 1, so count is now 6. Again, we go down to line 11, I equals I plus 1, so I becomes 5. Let's see what happens this time. So while I is less than 13, well, I is 5, and that's less than 13. So we go down to line 5, and we're looking at pattern I equals pattern I plus 1. Well, 5 and 6 basically on the indexes, as shown at the top by the arrows. So we're looking at index 5, which is 0, and index 6, which is 1. Well, those aren't the same, so this time we go down to line 7, and then we would go inside of that else, so we'd end up at line 8, and we would print out the count. So we're printing out 6, because this indicates how many zeros that we counted. We would then go down to line 9 and print out 0, because we're saying there were 6 zeros, and this is how RLE works. Now obviously this isn't the end, because the condition on line 4 still isn't met. So the program then would go down and increment I on line 11, and it would keep looping round until the condition on line 4 was satisfied. Now obviously I'm not going to do that, because I just wanted to recap how it worked for you. I'm going to show you the difference between 1D arrays and 2D arrays, so this makes up quite a large proportion of the marks on your exam. In a 1D array, we've got indexing like this. So at index 0 would be Ford, at index 1 would be Volvo, and at index 2 would be BMW. And this is using 0 indexing. This is the correct way to do it. In your exam, it might say, or might not, it might say using indexing of 1. If it does, Ford would be 1, Volvo would be 2, and BMW would be 3. the correct way in programming is indexing of 0, which is Ford is 0, Volvo is 1, BMW is 2. In 2D arrays, it's an array inside of an array. So here, the indexing to start off with is the same. So at index 0, 1 or 2, it would grab these. So index 0 would be 0, 0, 0. The index 1 would be 0, 1, 1. The index 2 would be 1, 1, 0. What happens if I wanted to grab one of the individual elements from it? Well, I would do it like this, okay? It would have a second number, okay? So you can see here that where there is 2 indexes. So the red index indicates the red section, and then the orange index indicates how to identify an individual element, okay? So let's have a practice. So image 1, I want to grab 1, 0. Which one do you think that would grab from, okay? So it would in fact grab this one here, because it goes to the red index, which is 1, okay? And then it goes to the orange index, which is 0, so it would grab 0, okay? 2D arrays is going to be on your exam. So here's an example of how one works. So here, I've got a program that checks if one image is in inverse of another. So before you look at the code, look at the image below. You'll see the image 1 on the first line indicated by red is 0, 0, 0. So an inverse of this would be 1, 1, 1. It's basically a flip of the result. So if you look at the purple row, 0, 1, 1, well the reverse of that would be 1, 0, 0. And then if you look at the green row, you've got 1, 1, 0, and inverse of this would be 0, 0, 1. So it's basically just flipping the individual images. So if I bring up image 2, you can see that it is in fact not an inverse of image 1. Okay, so this is what the code does. So now we're going to step through the code to see if you understand what's going on. Let's see how the code works. The first 4 lines just initiate the variables that are going to be used, as shown here. We're now at this while loop. Well, I is 0 and it's definitely less than 2, let alone equal to. So we go inside. We set j equal to 0, and again j is definitely less than 2, so therefore we continue. Okay, so we come down to the if statement here. Now we're going to go to the index for each of these. So in image 1, we're going to 0, 0. So that would give us 0 as indicated at the top in orange. And for image 2, we're going to go to 0, 0 as well. And we can see that that is 1. Well, those aren't equal to each other, which means that at the moment, our image is still an inverse. Okay? Because obviously 0 would be white, 1 would be black. They're the reverse of each other. So we come down, j equals j plus 1. So j now becomes 1. We come back round the loop. So j is 1. Is it less than or equal to 2? Well, it is. So we come down and we're back at the if statement. So now we're looking at 0, 1. So for both of them, we go to those indexes. So at index 0, 1 for image 1, it's 0. For image 2, it's 1. Well, 0 and 1 are not equal to each other. So at the moment, our image is still in inverse. So we come down again and increment j. So j is now 2. So we come back around the while loop. Is j less than or equal to 2? So at this point, 2 is equal to 2. So again, this condition is still met, so we go inside. If image 1, ij, so now we're looking at the index of 0, 2 for both of them. So for image 1 it is 0, and for image 2 it is 1, as shown at the top in orange. And again, those are not equal to each other, so at this point, the first row of our image is an inverse. So we come down again, and j equals j plus 1. So at this point, j would be 3. So the nested while loop of j is less than or equal to 2 is now complete. So we come down, we'd make I equals I plus 1. So now I is equal to 1. And we go back up to the top, and now we're restarting this while loop again because I, okay, is less than or equal to 2. I is 1. So we are, again, back in this loop. Okay, so you can see here that it would continue around. Now, if you look at image 1 and image 2, in the second set, you can see that there is a 1 and a 1. At this point here, the inverse of our image would become false. Okay, there will be something that pops up on your exam that's like this, so I hope this helps. I'm not going to go through the whole code, but if you were to copy and paste this to REPL, it would work. I've added lines 9 and 10, so if you did copy this, it would make it easier for you to understand. Obviously, this is presuming that you watched this video as advised before the day of your exam. Thank you for watching. Good luck.